Hi everybody, Ben Pouladian here of BEP Research, live from Google Cloud Next at the NVIDIA booth with Dave Salvator, Director of Accelerated Computing at NVIDIA. What a crazy few days it's been with all the announcements on GPUs, TPUs, and cloud computing. And I wanted to loop in Dave to give him some of his thoughts and some questions that I've had about what's going on in the market and what NVIDIA is doing on the cloud front. Nice meeting you, Dave.
Great to be with you, yeah. So, lots going on here at the show. We've had some great announcements. We've had a long partnership with Google that spans more than a decade, and here at the show we've announced, along with them, the A5X instance coming online here, I believe sometime this year, based on our Vera Rubin platform. They have a networking technology that they've introduced here called Virgo, which will enable them to scale out the number of Vera Rubin GPUs out to as many as 960,000 GPUs across multiple sites, or even 80,000 GPUs within a single site. So as we think about operating at scale, and we think about where we are in this agentic AI journey and the fact that we need that performance at scale, Google's really set themselves up with this platform to be able to deliver a lot of performance to their customers.
Yeah, so Google has this Taurus architecture. It's like a 3D spine. And I guess what's interesting is that NVIDIA has NVLink and InfiniBand that came from Mellanox.
And Ethernet as well now. Yeah.
So it's interesting how Google is applying its own optical networking technology with NVIDIA GPUs. Am I reading that right?
You are, and in addition, that instance, by the way, the A5X instance will also be using our ConnectX-9 network interface cards as part of that overall solution. And we do a lot of co-engineering with Google to ensure that not only they're getting great performance, but also great scaling efficiency to get that performance. Because it's one thing to throw more hardware at a problem, it's another thing entirely to get really great scaling efficiency so that you get the return on the investment of that incremental hardware.
Right, and the theme of the last 2 days with the keynotes and everything was mostly agentic workflows. Obviously, agentic workflows are more compute intense and use more tokens as well as CPUs. So how does NVIDIA fit into that with Google Cloud?
Well, Google has their own models like Gemini and Gemma, both of which run on GPUs, by the way. And one of the other announcements we had here at the show is that the Gemini model is now available on NVIDIA GPUs running on-prem in a solution called Google Distributed Cloud. And so this will not only be using our Blackwell technology, but it will also be using confidential computing so that the model, its weights, and the prompts and everything going into it remains secure. So for those organizations who want to be able to have the power of a Gemini model and have it on-prem, this is a great solution for them. But in addition to that, we also have our Nemotron models, Nemotron Super most notably, which is now available in the Google Enterprise Agent platform Model Garden. And so they have a number of our Nemotron models available, with Nemotron 3 Super being the latest edition.
Yeah, Nemotron to me is like an underrated hero open source free model that the whole world or enterprises can use, and open weights and open models is definitely where it's at. I think it's a great model and great product that people really need to spend some more time talking about. And something else that I feel like doesn't get enough attention, I know at GTC they unveiled Dynamo 1.0, which is, in my opinion, orchestrates the whole data center as a factory from the top down, and everything is controlled. And I feel that's how NVIDIA is really squeezing out 2.7x more performance on the same hardware by not changing anything. I mean, how do you guys do that? That's crazy.
Dynamo is certainly in that 2.7x. You think you're referring to some work we did on the MLPerf inference benchmark recently, and we're very proud of those numbers. Dynamo is a phenomenal solution because it's built from the ground up for agentic AI. One of the key things with agentic AI, and inference in particular, is this notion of taking the two big pieces of the inference operation. One's called prefill, one's called decode, and basically being able to take those and break them apart and put them on different GPUs. There's something we call disaggregated serving. And that, as it turns out, is a great way to be able to load balance those two things and apply the right amount of hardware to each one, because they have different performance needs. As an example, the prefill portion is more compute intensive, whereas the decode portion, which is what generates all the tokens after the first token, is much more compute intensive, right? And so being able to right size the amount of compute you're using on each one is going to get you to that optimal performance. And another piece there, of course, is that it all runs on things like our GB200 and GB300 architectures today, and in the future, Vera Rubin, where you're running on that NVLink domain with 72 of our GPUs, and they can all communicate with each other very, very quickly over NVLink, which is another critical thing that helps us get optimal performance.
Yeah, coherence and speed is a big deal. I don't think people really pay attention to that. I think that's very important. At the same time, having all those things working together in unison and having that co-design, right? I saw the email this morning from Jensen it was like everyone use Codex 5.5, and having that co-design partner, which is most likely OpenAI, asking the needs of or basically the roadmap of where the agentic or the software layer is going, and then driving that into the hardware and recursively having it go back and forth, I think is a really interesting aspect of how things are being done at NVIDIA.
It is. I mean, it certainly is, as you say, there's a cycle, a design cycle dynamic that goes on there to help us build those next generations of hardware. And one of the key pieces, of course, is delivering not only phenomenal performance at scale, but also thinking about it from getting great TCO.
Right.
And in a lot of ways, we think of performance as ROI. In other words, the more performance we can deliver to someone on the same platform they've invested in, that's value we're basically giving to them that increases ROI, reduces costs, and lets them do more with the hardware they have today.
Yeah, because the future is just massive token factories, right?
That's right.
Producing intelligence, that's where we're headed. The question is, do you want to pay for the best product up front, which in my opinion is probably NVIDIA GPU because of the CUDA platform, and at the same time, the increases in performance that you get with the co-design and the software, or you can go out and try to build your own custom program. Hopefully it tapes out in 2 years, God knows where the models are and the training, and then by the time you use it, it's like, you can't really use it for anything. It becomes like an artifact. And I think that's what some people have a hard time understanding, is that because it's cheap up front doesn't mean it costs you more on the back end.
That's a really good point, and that's something that we also think about a lot with our platform, and we have really since the inception of deep learning, is trying to balance great performance with versatility. And also sometimes what infra managers like to call fungibility, which is an ability to do a lot of different things. Because in addition to the great performance we deliver on training and inference in the AI space, we also deliver phenomenal performance with traditional machine learning, data analytics, visual computing, and scientific simulation are just, that's kind of the short list of things that we can accelerate. And so getting that right balance between, again, being really good at the things that the market cares about, but also being able to ably handle other workloads is something that really goes into pretty much every product we build. And I think that's another reason why you see, a lot of customers really like the NVIDIA platform, because we're not only the platform of today, but we become the laboratory for tomorrow.
And then I've seen something floating around recently. People are generally saying that now AI can write kernels autonomously versus writing them by hand, and it supposedly decreases the NVIDIA mode. I don't see it that way. Because some people said that NVIDIA's used cursor to basically improve some of the speed ups on CUDA. What can you say about AI and CUDA kernels?
We think actually using AI to tune kernels is fantastic. I mean, it's something we've been doing internally at NVIDIA for some time. We've done a lot of work with cursor. And so that work includes some recent work we did on over 200 different kernels, where on average, we were getting about a 40% speed up coming from just using agents to tune those kernels.
Oh, wow.
Other organizations like, say, ByteDance, or another one who's actually an inception member of ours called Right Now, have seen even bigger gains on the order of like multiple X factors, I think as much as 14X more performance, and something on the order of about a 92% reduction in cost. So the ability to take what, the great technology that's in CUDA today and in our kernels today, and further extend that, just brings more value to the platform.
I see. And then lastly, in your 30+ year career in Silicon Valley in computing, how do you see this last 5 to 10 years versus the rest of the?
Really been a rocket sled ride. It has been incredibly exciting. The rate of innovation, the rate at which we see the capabilities of AI expanding and growing and improving, and the innovation that NVIDIA has been able to bring to the market, year upon year with our annual product cadence, has been amazing to watch the speed at which this market is growing, and the rate at which AI is really improving and bringing a lot of positive impact to multiple industries, and really helping people be better at their jobs and be able to do more with technology. It's been phenomenal to be part of this.
Well, that's a wrap with Dave Salvator, Director of Accelerated Computing. Thank you very much, and have a great day.